Hello, and welcome to part 2 of this weapon trace tutorial. Now, if you haven't seen part 1, what are you doing? You need to watch part 1 first, because in part 1 we have made all of these functions and set up their inputs, as well as some other things that need to be set up in order for this to work. So, in this part, we are going to fill some of these functions in and see if we can't make a basic weapon trace functioning. So to begin, I'm going to split this pin so we can immediately see all of the needed variables. And let's start by putting the set current and last trace points function right here. Whoops. If I can, there we go. And plug in the start socket, the end socket, and the number of points. When I just realized I need to add the extend amount to this, which is a float. All of that's set up, and I still managed to forget these things. Oh, and of course we need the weapon, which is a scene component. There we go. And hook up the weapon. There. But of course, this function won't do anything because it's empty. So let's go ahead and fill this one in. First, we need to get socket locations. And let's just hook these ones up. I doubt I would have forgotten anything in here. So let's go ahead and make this function. I'll put this up here. And we just need to turn our sockets into vectors. So let's go ahead and get the weapon, say get socket location. For the start socket first, and then let's duplicate this to the end socket. And the start socket is easy enough to return, because this is just the location of the start socket. For the end location, it is not the same as the socket location, and it turns out I did forget something in here. I promise you I make a script for these, I just never managed to follow them properly. Let's see, this is the extend amount. And it is a float, because we need the extend amount to get an extended end location if applicable. So we need to make a forward vector out of the socket locations. So let's use the find look at rotation. The start being the start socket, the target being the end socket. If you would like to make a version that has an extend amount that goes backwards, then you could make another variant of this, maybe add a boolean to have the extend amount backwards, or a negative extend amount, and have this just turned around so that the start is at the end location and the target is the socket location for the start, which means it will go from end to start, meaning it will go backwards, and you can have an extend amount going into your weapon instead of outward from it. So this look at rotation, we need rot from x vector, what is it? Or what is it? No, we just say forward vector. Don't need to make a rotation, it makes a rotation from this. The forward vector, multiply this by a float, that being the extend amount. Let me make this look a little nicer by adding some reroute nodes. And this needs to be added to the original location of the socket. And this finally becomes the end location. So then, back in the set trace points, we now have our get socket locations. You can hook up the extend amount here. Let me switch these two up. There we go. Looks a little neater. And then the number of trace points on this one will be at the bottom, like so. These will go into the calculation of the trace points. So here we say calculate trace points. The start location and end location go here, and the number of points, goes in from the base of the function, which you don't necessarily need this. You can also say get number of points, which will get this as a local variable as part of this function. But I don't think it's far enough away for me to do this. Another disadvantage of using that is that if you change this name, then that reference becomes broken. So I tend to avoid it if I can, but use it if I must. And so let's go ahead and calculate these trace points. So in order to calculate these points, we need to loop over the number of trace points and calculate parts between the start and end location as a sort of percentage between the two. So let's make a for loop. And hook this one up to the last index, but actually we need to subtract 1 and then use the last index, because the number of trace points, if you have 6 trace points, then it would loop 7 times because the first index is 0. So it would do 0, 1, 2, 3, 4, 5, 6. That's 7 items instead of 6. So instead of having 6 as the number of trace points, we have 6 minus 1 as the last index, because the first index is 0. Now we do need the index to be 0, because the index is something we use in a division later. So if you wanted this gone, you could put the first index to 1, but then you would need to do subtract 1 later. But I like it this way, so I'll keep it this way. So then in the loop body, we are going to make a bit of a calculation. We need to convert this to a float and call the safe divide function. And duplicate this, hook this up to the B, and put this in here. And this safe divide will be part of a lerp vector, which means the divided percentage between the start and end location will be stored into our points. Let me see. Yes, so here is a part where I would say get start location and get end location. And these need to be added to a local variable, which I will call loc underscore trace points, which is an array of vectors. And we will say add unique. That's all very far away. Let me put this a bit closer. There. So now we just need to return this array. Whoops. I keep missing. So to recap, we loop over the number of trace points, then the current trace point that we are trying to calculate is divided over the maximum number to get a percentage, and that percentage will be lerped to the start. That percentage will lerp the start and end locations of our mesh to return the trace points that it will store into the current or last frame points. So we are outputting these trace points. Now the thing is, this does not differentiate between current or last points. We need to do that with 2 new variables. So let's call this current trace points, or maybe a better name would be this frame points and last frame points, both vector arrays, and then we set this because we just calculated this. So we set this to the trace points of this frame, and let's grab the return node, whoops, and output this as this frame, and then we get the last frame points and put them in the last frame, but we never set the last frame, so we need to do that before we calculate the new ones. So we get this frame points, put them as last frame points, and set them just before calculating the new ones. So when we execute this function, we get our locations. This could be before or after. I like to put it here because then these connections don't overlap as much. So we execute the function. The frame points that we had before are set to the previous frame points. Then we calculate new points and set them to this frame points. And then we output these results. So then that'll about do it for the setting of the trace points. Let's go back into the MeleeTrace and actually loop over all of these. So let's drag out here and press F to create a for each loop. And then off of the last frame points, let's see, we are going to loop the draw traces function. And this will be going into the start frames because we are going to trace from the current to from the last frame to the current frame. So we need to get a ref of the array index, which these should be the same length. So if we get the array index from the one, it should be the same one as from the other array, and output this into the end. Now we can just hook up all of these, so I can just get the radius and the debug type, as well as whether or not to use a line trace. And the other ones I'm going to make myself, but I will be doing this later. For now, I will be setting the trace color to cyan. As for the object types, I'm going to say make array. You could parameterize this, of course, inside of your MeleeTrace function, but I like to do this. I will be tracing for world static, world dynamic, and pawn. And for the ignore actors, I will do the same thing. I will say make array and say get owner. Make sure to get the one for the component because this will get the self. And we are currently, self is an actor component, and the other one is an actor, which will return an error because self is not an actor, it is a component. Then I will duplicate this and say for the weapon to get the owner as well, because this weapon may also be traced if you don't do this properly. So you will end up attacking your own weapon, which makes no sense. If you have the collision set up to none, then this shouldn't really happen, but even still, I prefer to do it this way. And if I'm not mistaken, this is kind of all we need to return a trace inside of an animation. Except, of course, we need to call this function in the animation, which we will do by making a new blueprint class of type Anim notify. Now, it is important, Anim notify state. It is important to note that if you followed the tutorial by Amber Scott that I recommended in the introduction video, you should use the timed Niagara effect, because in that case, or just put the following functions inside of the timed Niagara effect that you already have. So if you've already followed that tutorial, just copy this, what I'm about to do, into the timed Niagara effect notify state. And if you plan to follow the function, I would recommend you make a timed Niagara effect now instead of later. But for now, I'm going to use an Anim notify state myself. I'm going to call this ans_weapon trace. Open this up and override getNotifyName first of all, and call it weapon trace, because I hate having the ANS underscore in all of my notifies. It looks ugly. So then we need to override the tick and get the mesh comp, say get owner. Whoops, that's not the one. Say get owner component. And from get owner we say get component by class. That component being our weapon trace. No, actually we need the get components by class. So get components, the one with the S, the plural, because we can have multiple of the weapon trace things. That is why we have the trace slot input. So let's see. Right, I totally forgot about variables. I need to add the trace parameters variable. And make sure to expose this. And I need a trace slot, which is an integer. And make sure to expose this one as well. So then let's hook up the trace slots to this get node so you know which of these slots to use. Now, unless you have specific variables per slot, it doesn't really matter which one you put here, as long as it's valid, first of all, and if it is not overlapping with another index or a slot in your animation. So then, because this needs to be valid, I'm going to say make an isValid check. This time I'm going to get the macro and hook this up here. So only if it is valid is it going to continue. If in any case it is not valid, I'm going to say return node with false. But if it is valid, I'm going to grab this and run the MeleeTrace function and hook up all of the trace parameters. And of course we need to get the weapon. So off of get owner, we once again say get weapon BP. Now the thing is, this is a blueprint and not a scene component, which means we need to get component by class and say skeletal, no, not skeletal mesh. Oh, this one isn't correct. Hang on. This needs some work. Let's do this one first. One moment. In the third person character, we are going to class settings, implement the trace. And here we say get weapon blueprint. In that case, I'm going to output the weapon blueprint first of all, but this shouldn't be the blueprint to begin with. I'm going to open this in the interface and say, call this weapon BP. I don't need this, but I'm going to keep it in case I do. I'm also going to say weapon mesh as scene component. So in here, let's see, I am going to find weapon base, open my weapon base, create a new function, call this get mesh, and return node outputs the static mesh as a scene component. And this just converts automatically because static meshes as a component automatically inherit from a scene component. So let me recap this. Right, so we have the weapon BP and say get mesh. This should be a pure function. And output the mesh. Alright, now here we can get the weapon mesh and plug it into the MeleeTrace. And this is the tick that is running. So let's just open my animation and add this to the animation. So if I can remember what that was called, I cannot. Let me find it. Right, here it is. If you remember my very first tutorial for motion capture animation, this was one of the animations I had made. I have 4 of these in the total moveset, but I will only be covering this one because it's a little more convenient. So let's call this, add a new track and call it trace. Add a notify state called ANS weapon trace. And by the way, if you're wondering what the input buffer here is, I have a tutorial on that as well. So you can take a look if you like. And I'm going to trace from, let's say here, up until here. And then let's set the trace parameters, have the start socket called start, the end socket called end, the number of trace points, let's start with 6, use line traces, false radius 15, extend amount 0, bounce percent, trace slot, owner's weapon, debug type, for duration. Let's see what this will do. Nothing, great. Oh, because we don't have the trace component in our character. So let's add the weapon trace component in our character. We don't have to set any variables inside of it. So let's try this again. Whoops, that's not the right button. Once again, we return nothing. Why not? Okay, I'm an idiot. I didn't draw the traces yet. No wonder they didn't show up. Let's see what we need to do here. We need, first of all, a branch for whether or not to use a line trace or a sphere trace. If true, we say draw line trace. No, that's not it. Line trace for objects. Multi-line trace, sorry. And we say get start, get end, get object types, get actors to ignore, get debug type, and get trace color. Whether or not to trace complex is your decision. I believe it is more expensive. It really depends on how you set up collision in your project in general. But my advice would be to keep this turned off unless you really need it for something specific. So then, I'm also going to need a sphere trace for objects, multi-sphere trace, again, sorry, and hook up these same variables. So the starts, the end, the object types, the actors to ignore, the debug type, and the trace color. And also hook up the radius. So say get radius. And we can return from both of these the same. Oh, whoops, that doesn't work. My fault. My goodness, I cannot aim today. Right, so now that we are actually drawing traces, perhaps we will see some of them when we draw, and indeed we do. You can see that it draws them in between each frame. However, there are some complications. So that previous frame, or the previous attack, it looked fine. Now then, let's say move over here, and we still have our previous frame stored. So now if I attack again, you can see over there, I just pointed at my screen, you can't see that, but you can see right over here that it still keeps those last frame points and draws from the last to the current frame, even though we are well away from it. So in order to prevent this, we need to reset our traces. So let's make a new function, call this reset traces. And what we reset in here are the last frame and the current frame points. We don't need to set them, we need to get them and say clear. And when we do this on the begin and on the end of the animation. So let's go mesh comp, get owner, say get component, no, multiple components by class, and say AC trace gets a copy of the correct trace slot, and say reset traces. And I'm going to copy this and put the same thing on notify end. There, so now if we try and attack again, the first one is always correct, and the next one is also correct, and it has no more of that super elongated trace between the previous attack and the current. Now then, one thing I wanted to show you is if I set the max FPS, what is it? Frame rate? No. What was it? FPS. Max FPS, let's set it to 20. So this is simulating a lower end device running at 20 frames per second, and you can see it still traces the attack. Now, granted, this isn't the same necessarily as the proper curve that you had for the bigger animation of the higher frame rates, but it still traces in between each of these points. So even if I were to attack this thing, you can see it still hits, even if we are in between. And this is the main advantage of a system like this. Even with a low frame rate, you can still hit all of your attacks. Now in here you can also play around with the radius and the number of points. For instance, if I wanted to have more points, I could add maybe 20 points. I wouldn't really need such a big radius. Let's say only a radius of 5. Let's try this out. And you can see that it still fills my my attack pretty well. There's no holes in between. So if I had a lower radius and a lower number of points, you would notice that there are holes in between. Granted, these holes aren't that big. It would take a lot of bad luck to miss an enemy with this, but I always like to be safe rather than sorry. Besides that, this will be useful for the next episode in which we will program the sweet spot and the bounce percentages, which is always more useful to have multiple trace points for. And one thing to note, though, is that these are some very small trace points. So, here is that game design thing that I was on about. I would recommend for the player to have larger hitboxes for their, or in this case, trace radius radii for the weapon traces, because it would make it easier to hit things. Because you don't have full control over how your character moves their arms. And sometimes it gets lost in the nuances of the animation where exactly you are going to hit. So in that case, it helps to have a larger hitbox to hit with. Now, I wouldn't recommend doing this for the enemy, on the other hand, because then it will start to feel a little unfair. You could be like, what, I was half a meter away from him, how could he still hit me? And besides, that is also a bad idea because it was used in Dark Souls 2, which means it's usually a bad idea if it was in that game. So that's why I would recommend doing a larger radius, like 15, for your player character with a lower number of trace points, and just a lowered radius for the enemy. So that'll about do it for episode 2 of this tutorial. I hope to see you again in episode 3, where we will be covering how to do the sweet spots, the bounces, and a little bit of where you would apply the damage. So that'll be all from me for today, and good luck.